Okay, welcome back with me. We continue to the second problem about the back converter. This is the back converter as shown in the figure of both can be used to step down the DC voltage VDC into a desired output voltage Vout. For simplicity, we just model the right hand side. This is this circuit, not this. Okay, but if you want to model this, uh there you go. But I just want to model the this right hand side. Okay, this right hand side, which is the connected to a LLC circuit as shown in the figure above. Suppose that the model of this circuit can be written using the following space representation, which is t the differential of x over t over time is equal to f function f of x and time. Identify the state vector x of the circuit and identify also the function of fxt. Okay, firstly we are asked to determine the state vector x, and then we are asked to construct the state space representation with the con with the input v in and output v out, and then we can draw like this. This is the I think the easiest way to solve this circuit is using the node voltage method, uh, which is we assume that this is the super node, or just we can say the node A, and then this is the ground, and we can apply the current Kirchhoff current law in the node A. We get the sigma current in the node A is equal 0, uh, which is we can assume that the current of the three wires is outward from node A. Then we can write minus EL of the current of inductor minus current of resistor and minus current in the capacitor flow in through capacitor is equal 0. And we can, because the formula of inductor current is using integral, which was value 1 over L integral V L dt. So I prefer to no to do not use it, but just leave the EL as the state, as the state, and we can get the current of resistor with this circuit. We know that the voltage in the node of resistor is node A and ground is node with value Vg is equal 0. So we can say that the voltage in the resistor is the Va, or equal the voltage in the node A. And if we look at this circuit again, we know that the resistor in this circuit is parallel with capacitor. Then we can say that the voltage of a resistor is equal the voltage in the capacitor. We can say that the Vc. Then we can write that the current through resistor is equal Vc over R. Then we continue that the current through the capacitor is equal C multiplied by differential of voltage over in this capacitor over time. And then with this equation, we can just determine that the state is EL, the current of the current through the inductor and the VC, the voltage in the capacitor. Then we can write dVc dt over dt is equal minus 1 over LC multiplied by VC minus 1 over C multiplied by EL, like this. Then the inductor, we just can observe that the voltage around inductor is the node A and the input voltage. So we can know that the voltage in the inductor is the difference of V in the node A, which is equal the whose value VC minus input voltage, and then we remember that the voltage in the inductor is equal L multiplied by del dt. Then we get the second equation, dl over dt is equal 1 over L multiplied by Vc minus 1 over L multiplied by input voltage. Then we know that the output voltage in this circuit is parallel to the capacitor. Uh, so automatically the output voltage is equal to Vc, and then we can construct the state space representation like this, and the V out is equal to Vc. Then we can write V out is equal matrix C with whose value the row matrix whose value 0 and 1 and 0. And because the output is not affected directly by the input voltage, which is no, which is the zero value. I think this for the second problem, and in the third problem, because we are asked to model the other system, I want to model the RDAC system, rotational translational actuator system, in the spreaded PPTX file, because I think it the modeling is more complicated than the two two problem this two problem. So uh, we will I will explain the modeling in the spirit explanation in the spirit PPT X file. I think enough. Thank you. Assalamualaikum warahmatullahi wabarakatuh.